Y28 hydrogen atom. Hydrogen atom is the bound state of an electron and a proton through a Coulomb force. Yes, experimental observations revealed that it has a discrete spectrum. Classical theory cannot explain this discrete spectrum, and the Rydberg constant represents a very simple formula to express in terms of a simple algebraic form. In 1913, Niels Bohr introduced a remarkable idea to explain this spectrum. Unfortunately, his idea reproduced the energy spectrum correctly. However, his theory is completely wrong. And the first exact calculation was given by Wolfgang Paulie, who has found the spin of electron. And spin is a kind of angular momentum. When we learn classical mechanics, angular momentum is only generated by the orbital motion, and L equals R cross P. However, there is no correspondent physical observable in classical mechanics that corresponds to spin, because spin of an electron, for example, a spin of an elementary particle, is the angular momentum that is present even if the particle doesn't move. Okay, Niels Bohr's idea will be explained a little bit. And his basic idea is electron has orbital motion. And his idea of orbital motion is completely wrong. Basic idea in quantum mechanics, one cannot determine the momentum and position simultaneously, so we cannot determine the orbit of an electron. However, by accident, his calculation is very simple. Electron has orbital motion, and we know that the orbital angular momentum is radius, even in circular case, radius multiplied by linear momentum. His assumption is that orbital angular momentum is an integral multiple of h bar. In that case, we know it is making a uniform circular motion whose centripetal force can be computed in such a manner. This one can be expressed as a Coulomb force between the electron and proton. Here m is the mass of an electron. We make use of the constraint that the orbital angular momentum is nh bar. We express the numerator in terms of orbital angular momentum. We have multiplied additional p's. We have to divide this one by radius squared in the denominator. Here, mass m should not be inside, m should be outside. Okay, so this is an orbital angular momentum squared, so that is h bar squared and n squared divided by radius q. This radius is now found to be equating this and this. We have r is proportional to some constant, and radius r is proportional to n squared. where n equals 1, 2, 3, and so on. And this special constant is called a Bohr radius. We apply classical mechanics to find the kinetic energy according to this relation and potential energy that are well known. Using this, sum of this will give a total mechanical energy, and the value is found to be like that. And this is mc squared. Mass is the electron mass, and actually it is it is more accurate if I make use of reduced mass because it is two-body system. M, 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 M. Capital M is the mass of the proton. And this energy level is exactly the same as the Rydberg constant formula. And here alpha is called fine structure constant. It is very similar to 137 numerically. All right, reduced mass, and this alpha is this number. From this, we can constant. You probably have been familiar with the 13.6 electron volt you learn in high school physics or chemistry. All right. This reproduction of Rydberg constant was by accident, and it is not a correct way of describing electrons' quantum mechanical motion, and that was first solved by Paulie. Now let us follow his calculation, but I don't want you to follow all of the detail. Let me summarize the final result only. This is the Schrödinger equation, time-independent Schrödinger equation, and we have potential energy that is due to the Coulomb force. Paulie solved this equation of motion for wave mechanics, and he reproduced the energy level exactly. Good. Another, he found that orbital angular momentum is quantized. This, as well as the principal quantum number n gives 1, 2, 3, but this principal quantum number is nothing to do with the orbital angular momentum. Instead, it determines the energy level of hydrogen atom. From this one already, Bohr's theory was wrong. Bohr's theory, he used the value of orbital angular momentum beginning with n equals 1. So it is impossible for him to consider the case of S wave that is called orbital angular momentum is 0. However, Paulie's solution shows that orbital angular momentum state does include 0, and the special value of the orbital angular momentum squared is L plus 1. Here, L runs from 0 to n minus 1, and n is 1, 2, 3, and so on. The z component of orbital angular momentum is called Lz, and this value is also quantized. And the quantized value for this z component of the orbital angular momentum is again proportional to h bar, but this integer runs from minus L to L. So multiplicity is 2L plus 1. In addition, he has found the spin. The reason is that because we do not have enough time, so we just say it is a spin. And spin is very similar to orbital angular momentum, but its value instead L runs from 0 to n-1. Spin quantum number is exactly 1/2 for the electron. And all of the energy, orbital angular momentum, and its a z component and spin quantum number, they are all quantized. The spin angular momentum is nothing to do with the orbital motion. It is nothing to do with the x cross p. That is orbital angular momentum. The spin angular momentum of an electron is the same as angular momentum of the electron in the rest frame of the electron. Because if particle is not moving, this angular momentum disappears. Therefore, the total angular momentum is the spin angular momentum only. There are only two values, either plus 1/2 of h bar and minus 1/2 h bar. That is the z component of the spin angular momentum. And Paulie has computed, found that state ket of a hydrogen atom is a linear combination of many states. They are all orthogonal. And n is called the principal quantum number, angular momentum quantum number, magnetic quantum number, and spin magnetic quantum number. And these states are all quantized, and the summation is all, over these regions. Okay, so if I want to compute the wave function in space, in coordinate space, what I need to do is to project out on the position vector. And that is factorized form. This is called the radial wave function. And this is a spherical harmonics. And this is a spin quantum, spin wave function. The radial equation satisfies this orthogonal relation, and when the orbital angular momentum quantum numbers are the same, all of the radial wave function with the different principal quantum number are orthogonal. This normalization is very nice to reproduce this canonical delta. The angle dependence, we remember theta and phi are the polar angle and azimuthal angle. The angle dependent contribution is closely related to the orbital angular momentum and its z component. And all of these states are normalized and they are orthogonal. This is a special wave function, the radial wave function squared, radial wave function squared, and r squared comes from the Jacobian. We have to consider this space integral. In the radial part, we have to multiply r integral, and this is a Jacobian. And the solid angle element is included in the angular part. And you will find this is N and L. This is a leading contribution. We find the probability of finding the radius is the smallest for the ground state. And as we increase the principal quantum numbers, the allowed values for the angular momentum quantum numbers increases. Okay, so these are listed in here. You will find the radius. This is just a probability. That means Bohr's computation was completely wrong. There is no way to identify the radius of an orbit. Orbit doesn't exist at all, and it is a kind of distribution all over the space. And the special value for the 1 over r, by making use of the state NLM, this gives 1 over n squared and a b, the Bohr radius. From this, we can determine the energy level exactly. And Paulie's exclusion principle represents that the number of electrons states, except for the spin quantum number, is there are orbital angular momentum states running from minus L to L, and for a given value of n that is called the principal quantum number, the sum is from L goes to from 0 to n minus 1. And high school student can sum this. This is 2L plus 1, and sum this again over L, then you will find n squared. However, the actual number of atoms are double of this. That means 2n squared instead of n squared multiplicities. So Paulie thought there is another quantum number, and it is now named as spin quantum number. There are two multiplicities, either spin up or down. Therefore, the periodic table is now understood using quantum mechanics.